Hello. In the last lecture, we talked about the rapidity of a moving object. We talked about speed and velocity. In this lecture, again we are going to talk about the speed and velocity. But the difference is, in the last lecture we talked about the average speed and average velocity. Now we are going to talk about instantaneous speed and instantaneous velocity. Now, what is the difference? Average speed means the average speed of an object for a time duration. During that time, it is not necessary, during that interval, it is not necessary the object will be having the same speed throughout. But average speed is always necessary to predict whether how rapidly the object has moved. There are instances when we need to talk about the instantaneous speed. As the name suggests, what is meant by instantaneous speed? Instantaneous speed means the speed of an object at a particular instance. Now, see the contradiction. If I click a photo of a moving car and will show you and will ask you, tell me what is the speed of that particular car when I click that photo. Can you tell me? You can't. You can't even know whether I have taken the picture of a moving car or whether I have taken the picture of a car at rest. What is the problem? The problem is in its definition. What is meant by definition? So we know that velocity is equal to displacement upon time. What is meant by displacement? Displacement is nothing but change in position. Remember that whenever you see the word change in all over the physics, you have to go for final minus initial. Here we are going to talk about change in position. That means suppose x2 is final position minus x1 is initial position divided by time. Now, interesting factor is here you are talking about x2 minus x1. If I write it properly, x2 minus x1 divided by t2 minus t1. Object is at x2 position at time t2, at time instance t2. Object is at x1 position at time instance t1. Change in position with respect to change in time. We are talking about instantaneous velocity, instantaneous speed. But whenever we want to find out the velocity, I need two instances. If there are two instances, then and then only I can talk about two different positions, because a particular object cannot be at two different positions at same time instance unless it's God. So we need to talk about two different positions, two time instances, but requirement is I want to find out instantaneous speed. So how to do? If we say an object starts from the A position, reach at the B position, the total distance between them is 2 meters, it takes 2 seconds to cover that distance, then you will say the weight is equal to 2 divided by 2, total displacement divided by total time required is equal to 1 meter per second. But now, this is unidirectional non-accelerated motion. To be precise, it is unidirectional uniform motion. Now when you say this is a unidirectional uniform motion, the average speed of an object is 1 meter per second. For the linear unidirectional motion, the average speed is equal to instantaneous speed, which means during A to B distance at any time instance, if I check what is the speed of that object, then speed of that object is 1 meter per second. Means for linear one directional motion, linear unidirectional motion, the average speed is instantaneous speed. But the problem arises when we start talking about non-linear motion. Consider this is a graph of the x displacement to time of a movement of a particular object. Now I want to find out the average velocity of this object. How to find out? This is the final position. This is the final position x2. This is the initial position x1. For x1 it was at t1 and for x2 it was at t2. So x2 minus x1 is divided by t2 minus t1 will give you velocity. If you want to find the speed of that object, find the total length of this curve divided by t2 minus t1 will give you the speed of that object. But in here, obviously, we know that if this is a non-linear motion, in this non-linear motion, at every instance, this object has different velocity speed. So how to find out at a particular instance, what is the speed, what is the velocity of that object? In this method, we are dealing with non-linearity. Remember that we cannot directly deal with the non-linearity. There are no tools, no predictions we can do with the non-linearity. So how to deal with this? So first of all, you have a road in front of your building. Is that road straight? Yes, it is straight road. Most probably, it is a straight road. Now, that road is part of earth. If it is part of earth, why that road is not curved? So whether the road is straight or whether the road is curved. So I'll tell you, practically that road is curved because it is part of earth. But it is a very small part of earth that you can consider as straight, linear. That means the very small part of non-linear thing can be considered as linear. When I see this non-linear curve and if I consider very small part of this curve, I can consider that part, very small part of this curve as the linear straight line. Now, if I say this is a very small part of curve, which is a straight line, means if I find for this straight line the average velocity, I am going to get the instantaneous velocity at each and every instance during that point. Now, putting that into the limit tending to 0, I can find out the average velocity. See, what I am going to do, suppose this is a very small distance dx. To cover that smallest possible distance, which compared to this whole curve is a linear thing, and we need very small time period dt, then I can say for this small period v is equal to dx by dt, total displacement divided by total time required. Now if I say that dx by dt is very small such that dx tends to 0, then I can say v is basically instantaneous velocity. See what we have done. For the whole non-linear thing, we talked about a very small part of it which is linear, which can be considered linear. If we can consider that small part as a linear part, the average velocity of that linear part can be considered as instantaneous velocity of the instances at each and every point. So this mathematical tool we can use to find the instantaneous velocity. This mathematical tool is called as derivative. Derivative gives you smallest possible change at a particular point. This is called as instantaneous velocity. The average speed and average velocity may be different, but the instantaneous velocity and instantaneous speed are always equal magnitude wise. Again, instantaneous velocity is a vector quantity like the average velocity. Instantaneous speed is a scalar quantity like the average speed. But magnitude wise, instantaneous velocity and instantaneous speed are always equal. Average velocity and average speed are not necessarily to be equal. Thank you.